So hey nerds, this is Suman, and in this video we're gonna talk about photons, the dual nature of light. So we are not getting into that part, but we are just getting into something very much interesting. If you heard about this fact that the energy of photon always remains constant when it travels from this medium to this medium. So it is very much interesting thing. So I do have some maths about this thing in order to prove it, but I would like to convince you by some theory portion, right? So when the photon travels from this medium and it comes back to this medium, what will happen to the photon? If you have heard about one key factor that the energy of photon always depends on its frequency, right? Or it depends on the source that is emitting that frequency of radiation. So when it travels from this medium to this medium, the velocity of photon changes. Correspondingly, the wavelength of photon also changes. So in order to conserve the energy of photon, the velocity and wavelength must have to shift in such a manner that its frequency always have to become constant. So this is the key part. So whenever someone is asking you when the photon travels from this medium to this medium, one might think that the energy have to be shift because the ordinary mind can tell that thing. But when you look up to the mathematical expression, it is not that the case. So when photon travels from one medium to another medium, its energy is always conserved, right? The velocity and wavelength compensate in such a way that it always gives a constant frequency. The whether it is a product or a division, the velocity and wavelength shifts in such a way that it always gives you the constant frequency. So let us dive into the whiteboard in order to do some math. So in order to understand why the energy of photon is always constant when it travels from one medium to another medium, let us imagine a boundary. The boundary is xy and we send some photons, right? The particle or wave, you can assume both at a single time. When the photon travels from this medium to this medium, it's slightly deviates from its original path. The original path could have seen like this, but it slightly deviates because when it travels from rarer medium to denser, the light bends, right? So one person might think in such a way that let the energy of photon in this medium is E1 and it follows Planck's radiation law. E equals hc upon lambda, right? And the energy in second medium will correspondingly change due to the change in velocity. Let us assume c naught be the velocity in this medium. This is not the speed of light, it's a velocity c naught. Velocity of light in that medium. And the wavelength correspondingly shifts. Let us assume that is lambda naught, right? Okay. So if the energy has to be changed, we can simply subtract the energy. E1 minus E2 gives you hc upon lambda minus hc naught upon lambda naught, right? Right. So if you have, let us assume mu A be the refractive index of this medium and mu B be the refractive index of this medium. So in order to evaluate the refractive index, you can actually do mu A into velocity equals c naught into mu B. I think you have heard about this Snell's law, and you will get c upon c naught equals mu B upon mu A, right? You can actually see from here. So you can write c. Let us assume E1 minus E2 equals h. So you can write c equals c naught. Let us assume this is mu dash or mu AB. It's a relative refractive index. I am just writing mu AB in the suffix, right? So mu AB. You can write h and c is c naught mu AB upon lambda minus hc naught upon lambda naught, right? So E1 minus E2 equals the hc naught will get common, and you can see from here mu AB. If you take LCM, it will be lambda naught minus lambda upon lambda naught. So E1 minus E2 equals hc naught upon lambda naught mu AB, right? And this is lambda naught minus lambda upon lambda. So if you see this from the second expression here, the hc naught upon lambda naught is nothing but the energy in second medium. So E1 minus E2 is E2 times mu AB lambda naught minus lambda upon lambda. So are you with me? Are you getting my point? Right? So if you take this E2 on other side, you will end up getting E2 plus E2 mu AB lambda naught minus lambda upon lambda. Right? And from here we get E1 plus E1 equals, if you take LCM as E2, so we'll end up getting 1 plus mu AB lambda naught minus lambda upon lambda naught, lambda. So E1 equals E2 lambda plus mu AB lambda naught minus lambda upon lambda, if you take LCM. So this plus lambda and minus 1 lambda will cancel out, and you will end up getting E1 equals E2 mu AB lambda naught upon lambda. So from here, let us assume from here, C upon C naught equals mu B upon mu A. So the C can be written as lambda F, and C naught can be represented as lambda naught F naught F, because the frequency of photon remains constant. So mu B upon mu A. So frequency will cancel out, and mu B upon mu A is nothing but mu AB. We are assuming that, right? So from here, so let us do it here. So E1 equals E2 into mu AB. So mu AB can be written as lambda upon lambda naught into lambda naught upon lambda. So E1 is nothing but E2. So it is the function of frequency. So you can make a beautiful prediction from here that when photon travels from one medium to another medium, the velocity and wavelength is shift in such a way that its frequency always remains constant. Right? So if you have n number of mediums here, and when photon travels from one medium and another medium, another, the energy part will be E1 equals, E2 equals, E3 equals, so on and on, equals En. So this is my time. Bye bye.